All right, now we're on energy conservation, section 4, and we're going to be talking about steady flow processes. But this is just a reiteration of the conservation of energy, that it can't be created nor destroyed. It can only be altered in form. So we kind of look at that. Conservation of energy. Give me a little tail on my G there. Right? Now, the first law of thermodynamics, if we're talking right up here in the first paragraph on the left-hand side, section 4.1, it says it right out of the gate. Energy can't be created nor destroyed, only transformed into one of the other forms. So let's look at what we know. We're going to be looking at the purpose of the reactor, how it takes feed water and raises the energy up. So there's obviously a process occurring here. There's a heat addition process. Then we're going to take that steam out, and we're going to try and convert that energy contained in that steam to motion in our turbine. Then we're going to have a thermodynamic process occur where we condense that steam in a condenser. So we're going to reject energy in this, and then we're going to have a thermodynamic process where we raise the pressure of the working fluid back up and send it to the reactor. So we're going to be looking at a steady flow process for each one of these. What is occurring as the reactor is raising the energy of this fluid? There is a conservation of energy. What is occurring across the turbine, the condenser, and the pump? And this will apply. We will be changing the form of energy. On the right-hand side, under section 4.1, you're going to see an equation. And it states, any heat that I add plus energy that goes into a process must equal the work that I take out. And look, this is very key, divided by a joule. That joule makes this equivalent to an energy, because I can convert a BTU of work to a foot-pounds force, or foot-pounds force to a joule, plus energy out. So this essentially is saying there's a conservation of energy. Any energy that you add, heat that you add, plus the energy that already existed, must equal the work that you extract out of it, plus the energy that's left over. Key. This is key. We're going to find out that we're just going to now take these two energies right here, and we're going to break them up into what those could be. And we've already talked about it. We know that those different forms of energy could come in the form of potential energy. It could be kinetic energy. It could have some PV energy, pressure volume. And the last thing was internal energy. These are the forms of energy that our working fluid could have, pressure, volume, and internal energy being the biggie, but they're going to have some velocity. They may have some height, plus heat is going to equal any work that we try and get out of all that, plus the energy that's left over in these forms. All right? So we'll get on with section 5.0 in the next video.